let's look at how to solve quadratic equations by using the square root rule. First, we need to understand one of the definitions for finding the square root of a number. So for any real number, if you have a quadratic function x squared equals a number n, you can cancel the squared by taking the square root of both sides. And when you take the square root, the square is going to cancel, and you're going to find the square root of the number. Now, we do know now that when you take the square root of a number, you guys will have a positive and negative answer because both signs will work. And something that is going to be really helpful to know is the vocabulary. So the symbol for square root is called the radical, and the number inside of the radical is called the radicand. So I'm going to mention those two words sometimes during the video. So radical, the square root, radicand is the number inside. When you guys use the square root rule, we need to know how to simplify radicals. So we are going to use two different properties, the product property and the quotient property. So when you have or find two numbers that multiply to the radicand, you guys can separate the radicals and you can simplify those radicals. Now the big idea for product and quotient property is if you have the square root of a number, radicand, and the number is not a perfect square number, you want to find two numbers that multiply, product, multiply 218 in this case, and one of them is a perfect square number. Once you find that, you can take the square root of that number, 3, and keep the other square root, the other radical. For the quotient property, the idea is the same thing, but we do have a fraction, and quotient property says you can separate the numerator and denominator, and each one of them is going to have its own radical, square root, and you're trying to break down, simplify, or factor, try to make the number smaller with the square roots. So for example, we have the square root of 2 over 25, you can separate the radicals, and we do have the square root of 2 on the top. Bottom, you can find the square root of 25, which is 5. One of the big things for fractions is you don't want a radical on the bottom of the fraction, so you have to get rid of it if you have one. So to do that, you just multiply the bottom and the top by the same radical you have on the bottom. So just remember that you do have to get rid of those radicals on the bottom of the fraction. Now here are some steps, and this is when you want to use the square root rule. I'm not going to read the whole thing, but I do want to emphasize on a couple things. So it says here you want to use this method when you do not have the b term or bx term. So you are going to have a, you are going to have c, but not the bx term. Or you might have a parentheses squared, meaning binomial squared. We talked about binomial squares when you factor. So you can have a binomial squared, or you are missing the b term. Okay, so notice we have x squared with a number. You can pause the video, read the steps. Okay, so let's go ahead and try a couple or a few examples. So notice, first of all, on the equation on the left side, we don't have the b term. So we do have a, which is with the x squared. This number doesn't have a variable, and this one doesn't have a variable. So those are not the b terms. So to solve, right, step number 1, you want to get the x squared by itself. This is using the square root rule, so get x squared by itself. So let's get rid of the number. We do the opposite. So this cancels. So we have 4x squared equals 25. X squared is not by itself, so we're going to divide by 4. This turns into a 1. So x squared equals, cannot simplify the fraction, so we have 25 over 4. Now the big idea for square root rule, here's the squared. To cancel the squared, because we want x by itself, you just take the square root. Whatever you do to one side, you are going to do it to the other side. So when you take the square root and the squared, that those are going to cancel. Keep in mind that when you take the square root, we need a plus and a minus. And using the quotient property, we can separate. We do have a fraction, so we separate the numerator from denominator, and we are going to simplify. So we do have perfect square numbers, 25 and 4. So we simplify that. So we have the square root of 25 is 5, and square root of 4 is 2. For the next one, once again, we do have the a. We have 3, no variable, 5, negative 5 doesn't have a variable. So there's no bx term, so we can use the square root rule. So first, you subtract 3 to get rid of that number. Our goal is to get the x squared by itself. So this cancels. So we have 1/3 x squared equals, and we have negative 8 over here. We are going to we're going to multiply by 3. So in order to get rid of the fraction, you just multiply by the denominators. So it's 3 here and 3 over here. So this cancels here. Keep the top of the fraction. So there's the 1. We don't need that 1. So x squared equals, and then we have negative 24. We're going to take the square root to cancel the square. So take the square root of both sides. Cancels, cancels. So x squared, and before I write down the plus and the minus, you guys notice we have a negative inside of the radical. So we haven't talked about imaginary numbers, but in Algebra 2, that's a big concept when you guys solve quadratic equations. But in the next videos, I am going to talk about those imaginary numbers. But for now, since we have a negative inside of the radical, meaning the radicand is negative, we can write down we have no real solutions. Once again, notice I'm writing the word real. We are going to have imaginary solutions later on, but for now, it's okay to have no real solutions. So let's go ahead and look at these ones here. They're a little bit different. So once again, we do want to use the square root rule. I do have a trinomial, and you guys can see the bx term here. And I said that you use the square root rule when you don't have the bx term. But I do want you guys to notice something about the trinomial. Don't do anything to the 28. Just looking at the trinomial, I can see that this number here is a perfect square number. I do have a plus next to it, so this is a perfect squared trinomial. So when you have a perfect square trinomial, you guys can factor the perfect square trinomial, and let me leave the 28 over here. So since this is a 1, I just need an x here. Perfect square number, use the square root of that number, so that's 6, square root of 36. We use the sign in the middle of the trinomial, so plus and plus. So once I factor those two binomials, notice x plus 6 is a binomial, x plus 6 is a binomial, they're equal. So I can write those binomials as a binomial squared. There's 2 of them, they're equal, so we have binomial squared. So look, now we have a parenthesis with the squared. That means we can use the square root rule. So to cancel the squared, we just take the square root of this side, take the square root of the other side. So this cancels, cancels. So we have x plus 6. On the other side, first I need a plus and a minus. I'm using the square root of 28. 28 is not a perfect square number, but I can find two numbers that multiply to 28. And you always want to find the greatest perfect square number. So 4 times 7, that multiplies to 28. And we know the square root of 4 is 2. So plus or minus 2, and just bring down the square root of 7. We want x by itself, so we subtract 6 from both sides. Cancels. So x equals, these terms are not like terms because 2 has a radical, 6 doesn't have a radical. And they must have the same radical in order to combine. But since they're not the same, we write the one with no radical first. negative 6 plus or minus 2 square root of 7. So this is the radical form. It's okay to have the radical. You don't have to turn into a decimal. So those are your two roots, zeros or solutions. And for the next one, notice we already have the binomial squared. So we can use the square root rule. But we have to get the binomial square by itself. We cannot have numbers outside of the parentheses. So I'm going to add 54 to both sides. So this cancels. So you bring down the 3, you bring down the binomial squared equals 54. Divide by 3. That's how you get rid of the 3. Do not distribute, you divide. So divide the other side by 3. This turns into a 1. So we have the binomial squared equals, and 54 divided by 3 is 18. Once we have the binomial square by itself, there's no numbers outside of the parentheses. Cancel the square, so we take the square root. Whatever you do to one side, you do to the other side. So the square root and the square cancels. So x minus 3. You have to simplify the radical. Make sure you have your plus and a minus. We use that when we solve. 18 is not a perfect square number, but we do have 9 perfect square number times 2. That's going to be 18. So that's how you simplify the radical. So we have x minus 3 plus or minus the square root of 9 is 3. Bring down the square root of 2. Get x by itself, so you add 3 to both sides. Cancels. So x equals, once again, these are not like terms. The bottom 3 doesn't have a radical. This 3 has a radical. So you just put them side by side. Start with the number with no radical. So there's my positive 3 plus or minus 3 square root of 2. So this is using the square root rule. Next video is going to be solving by completing the squared. And I'll see you guys next time.